Hi everyone, and welcome back to our IGCSE Computer Science lecture series. Today's topic is binary to denary conversion. In the last video, we covered denary numbers into binary. Now we go the other way. We start with a binary number and we work out what denary number it represents. The good news is that this method is more straightforward than the one we used in video 2. So let's get started. Now here is the main idea. Each binary digit gets multiplied by its place value. Then you add all of those results together and the total is your denary answer. You can see a short example on this page. Now the binary number here is 1011 and each digit is multiplied by its place value. So we have 8, 4, 2, 1. We multiply them and then we sum them up and the result is 11. So 1011 in binary here is actually 11 in denary. Now let me walk you through the full method with a complete example. Now we have the binary number 01001011 here, and we write it into its place value table. So wherever there is a 1, we note down the place value. And wherever there is a 0, we ignore that column entirely. So in here, as you can see, we're multiplying each digit by its corresponding place value. And then we're adding all of the results. And voila, we have 75 being the result, which means that this number in binary is the representation of 75 in denary. We can check another example here. So the binary number we have here is 11010110, and we want to convert this number to denary. Again, you only need to look at the columns where the bit is 1. So we have 128, 64, 16, 4, 2. And you multiply all of these columns, then you add them up in here, and in the end you get the result, which is the denary representation of the binary number that you wanted to convert. So this thing where we ignore all the 0 columns and we only focus on the columns where the digit is 1 is a very useful shortcut that makes our lives quite easier when we try to convert. Now here are some key takeaways from this video. First is that you write the binary number into the place value table. So just like in this example that we have here, you add the column values wherever the bit is 1. So as we've shown before, you add all of these results, and you ignore all of the columns where the bit is 0. So together, videos 2 and 3 cover both directions of this conversion, denary to binary and binary to denary. Remember, in the last video, this was the mantra for the conversion, and in this video, this is the mantra for the conversion. And in the next video, we will introduce hexadecimal. This is a different number system that is used extensively in computing and one that builds directly onto what we have just learned. So see you there.